Hello and welcome to the second appendix to the tutorial on writing your own operating system. Now, where are we? Last time we wrote code for handling Ethernet frames, which we get from the network driver. And Ethernet frames looked like this, and this Ethernet frame handler checked, well, is this Ethernet frame for me? Does it have the correct MAC address? Is it my MAC address or a broadcast? And if so, it looked at the ether type and would then forward this data block to the handler for that ether type. So, but we didn't have any handlers for these ether frames. So this is what we are going to do today. We're going to write a handler for the ARP because that's quite simple. ARP is really for the communication between computers. When one computer wants to know the IP address of another computer. So, not only that, but that is what we will be using it for. Again, the Wikipedia page about this protocol, again, is very good. So here you have, again, a nice description of how this data structure is built. Yeah, and an ARP data block looks like this. You get you get 2 bytes, which tell you the hardware type. Yeah, I think it's it tells you, is this going through Ethernet or is it going through something else, maybe wireless LAN or something. I don't know. So in our case, this will always be 1 for Ethernet. But actually, this is a 2-byte value, and it's big endian encoded. So this will actually be 0x0100, the big endian encoding of a 2-byte 1. Then we have 2 bytes for the protocol. We already have an information about a protocol, this ether type, which will be 806, hexadecimal 806. But the protocol that we have here is not the same as here. So this tells us, hey, we are talking about IPv4, so this would say 0x800. Okay? So here you would have 806, here you would have 800, because we are talking about, this is an ARP message, but this message talks about IPv4, which has code 800. And again, this is big endian encoded, so actually you would have 0x0008 in there. Then you have 2 fields of size 1 byte, which tell you the size of the hardware address. So this would be 6, because MAC addresses have size 6. And here we have 4 because IP addresses have size 4 byte. Okay? So this is the size of a hardware address, and this is the size of the logical address, an IPv4 address. And then we have 2 more bytes with a command. So this really tells us what does the sender of this message want from us? So does he ask us, what is your IP address, or is it a response to our question? Maybe we have asked him, what is your IP address, and this is a response. And these are actually the only two commands that we will implement here. Okay. Yeah, and after that you have uh, 6 bytes, 4 bytes, 6 bytes, 4 bytes, which contain the MAC address of the sender, the IP address of the sender, the MAC address of the destination, the receiver, and the IP address of the receiver. Okay, so this is what we will get. Yeah, of course, if the command is hey, tell me your IP address, then this won't be a legal value. Or maybe if we get it from a broadcast, then this MAC will be just the broadcast address. I mean, when we send something back, we will copy this block here because, yeah, we are sending this back to the sender of the message. So this stuff which said, so this is the info about the sender, and he becomes a recipient of the answer, of course. Okay. But actually, not all ARP messages have this exact length. Okay, so the length of the stuff here after this command, this is actually, this can differ based on these two values. You know, you have this many bytes here, this many bytes here, this many bytes here, and this many bytes here. Okay. But we will really hardcode this to be 6 and 4 bytes. Okay. Yeah. So, yeah, of course, one thing that is left, right now we have no, I mean, the ARP class needs to know the IP address of the machine because, yeah, how would you answer the question for your IP address if you don't know your IP address? So, so he needs to get the IP address somehow. But we have in the class for the network card, we had this init block, and this one had 4 bytes for an IP address. So I think what we will do is we will just tell this class, hey, this is your IP address, and he is supposed to ask him, and he is supposed to ask him. Okay? Yeah, that I think makes sense. Okay. So here in the ether frame we had this ether frame handler. So ARP is going to be an ether frame handler. So we will have a structure for this, for such a message. So, uint16t for the hardware type. Protocol address size. Which will be 4 in our cases all the time. So here we have the MAC address of the sender. Oh, I see this we should have done this here also, I think. Okay, 32-bit for source IP address, 64-bit for destination MAC address. Okay. By the way, if you ask yourself, why do we have the MAC address here again? I mean, here we have the MAC address of the destination and of the source, but we also have these MAC addresses here and here in the Ethernet frame header. So you might think, yeah, why have them here again? You could just look at these instead. But there's a problem. You cannot do it like this. You cannot say, well, I'll just leave them out and just use them instead, because there can be multiple machines between the sender and the source, the sender and the destination. Okay, so when he wants to talk to him, then his MAC and IP address will be here, and his MAC and IP will be here, but he will have to send the whole thing to him first, and when he communicates with him, then the source will be his MAC address and the destination his MAC address, not his MAC address. Okay? And then when he communicates with him, then this destination will be his MAC address, and this the MAC address from him is the source, and when he talks to him, then the source is his MAC address and the destination is his MAC address. Okay? So this is really the absolute low level for the communication between one machine and the next machine through maybe one cable. Okay, but yeah, as I've said, if he wants to know his IP or MAC address, then and he doesn't communicate with him directly, then this will always be his MAC address, and this will be his MAC address, and these can vary between them. Okay, on the path between them. So. By the way, at the end of the last video, we had this little error when I ran the code, where we got an instantiation error from the memory manager. Don't worry about that. That came from a problem. I was running an old version of the network manager here, not the one that I've shown you. So if you did everything I did in the video, then you shouldn't have gotten this error. Okay, this backend, we need to pass that to the constructor of EtherFrame handler. Now what we have to do is we have to override this on EtherFrame received. And I will also write something so we will give this an IP address in Big Endian encoding, and we want it to send a request for the MAC address of this IP address. And when we receive an answer for that, we will basically really store this in an area. I mean, this isn't really a great design, but I'll do it like this. So maybe have something like 128 IP addresses. So we request a MAC address for an IP address, and when we get an answer, then this is going into this on ether frame received method, and there we will store it. And then we'll have a method that looks for an entry in that cache. Okay. Okay, so the ether frame handler, the ether frame provider, as I said, is supposed to give us an IP address. Which it is supposed to get from the driver. And the driver will get this, this is, you could get this from a dynamic host client protocol, DHCP. You could get this from a DHCP server, but I don't know, I'm not that familiar with DHCP, so we will set this IP address manually, like you did it in the old days when you configured your network manually. So now So now we have a way to get the IP address. Okay, so the constructor, we'll call it a base constructor. Ether frame handlers get a backend and an ether type. Yeah, the ether type was 0x806. Okay. And here we set this num cache entries to 0. Okay, so in this reading something from the cache, we will just iterate through the cache, and if we find something, return it, and otherwise we will return 0. Okay. Okay, so like this we can read something from the cache. Of course we need a way to write something into it also. Okay, when we want to request a MAC address, we'll just instantiate such a message block on the stack. So big endian encoding of number 1. We're talking about IPv4. So an address size for protocol IPv4 is 4 bytes long. Oh, what have I done? I forgot the RAM for the command. Okay, so we set this to the command 1, again big endian encoding, so 0x0100. Do we have a method to get the MAC address from? No, we don't. So the Ether frame provider can ask the the AMD, so the network chip backend. Now we can ask the Ether frame provider. So we set the source for this request. This is us. Then we set this to the broadcast address. Okay, so now this message is finished and we can send it. So we send this to the broadcast address. Wait. We have inherited this send message here where we don't have to specify the ether type manually. So we don't have to send this to the backend manually. We just call our own send method, which we have inherited. So the buffer is just the address of this ARP message, and the size is size of address resolution protocol message. Okay, so this is how we request someone else's MAC address. So we say we want to talk to this machine, but we don't know its MAC address yet, so we send a request for that. Okay, now okay, when we receive such a message, we cast it to the message type first. That's relatively normal. But we should only do this if the size is large enough. Okay, so now we just, now we can check these values here. So if it's an Ethernet message, then we check. In the end, if nothing else happens, we return false, by the way. So the default behavior is to not send anything back. So only in these cases can we do anything with it. So if we can do anything with it, I mean, if we understand this message and it is for us, I mean, if it's not for us, then we might look into our cache for the requested IP address and answer the request with our cache entry. Maybe. So somebody wants to know the MAC address of some machine, and if we know that MAC address, we could answer it. But no, in this case, I'm not going to do anything. Or otherwise, we might want to pass the request on to some other machine, but but that would be the behavior of a gateway, and I mean, we are not making a gateway right now, right? So if the message is for us and we understand it, then then we look what is the command. Okay, in this case, 0x200, this means we have gotten a response to a request that we have made. And then we would just insert the response into our cache. Okay, so in this case, we just put this. Although this is a bit, I mean, if we get a response for an IP address that we haven't asked for, maybe it's not a good idea to store it somewhere. But I mean, these messages are unreliable anyways, so if we ask the network, hey, what's the MAC address of this and that IP, someone might answer with his own MAC address, even though it's not his IP. So if you ask maybe for the IP of google.com, and someone answers with his own MAC address, then effectively you will be talking to him whenever you make a Google request. So, and he behind that, he might talk to Google and answer your requests, but he might read and what you are doing, and he might change the results. And so this is really a point where a man-in-the-middle attack can happen through something called ARP spoofing. But I think this is just unreliable. I don't think there's really something you can do against it, because you're getting some data and you just cannot validate that where it came from. Maybe if you did something like communication through SSL, but then you need the private key of the other machine, and not the private, the public key of the other machine, and I think, I'm afraid we have no other choice than to trust this message for now. Okay, so if we are asked for our MAC address, then we change the command into a response, because we will be sending it back in the end. By returning true. So we change the command into 0x200. Now we turn the sender into the recipient. And the new sources is gonna be our IP address and our MAC address. Okay. This should really do everything we need at this point. So, one more method that I want to include. So here we can request a MAC address, and then later it will be put into the cache if we are lucky. And after it's put in the cache, we can get it from get MAC from cache. But I want to have something like a method that sends the request, waits for an answer, and then returns the MAC address. So first we look if we already have the MAC address in our cache. If not, then we request it. So this is what we get if the MAC isn't in the cache. Okay, so this isn't really safe because if the machine isn't even connected, then of course you will never get an answer to this request, and then you will never get an entry in the cache, and then this loop will never terminate. So we should have some way of finding out of having some timeout here, but yeah, I'll leave it like this for now. Okay, so I'm gonna put it in the make file. And in the kernel. So yeah, I think this was an IP address that VirtualBox will accept, 10.02.15, I think. Then the gateway is 10.022. Okay, now so our own IP address, again in Big Endian. Then IP3, IP2, IP1. Okay, so this is our own IP address. So now we have told the network card that this is our IP. So that the other layers can request it from there. And the address resolution protocol is attached to the Ethernet frame handler. Okay, so Here we attach the Ethernet frame to the driver, and now we attach the address resolution protocol to the Ethernet frame. Okay. And the gateway IP so now we have something that in theory should really be able to talk to the network. You know, before we could just send some stupid data that didn't mean anything, and everything in VirtualBox just so the gateway in VirtualBox just discarded these messages because it couldn't do anything with them. But I'm really interested what happens now, because I mean, we have really a lot of code for the driver, for the Ethernet frame, and now also for the ARP. And most of this we couldn't test so far. So this is really the test for all three of these things, and I'm a bit scared that this might not work. So I'm gonna do something like, okay, we can get an answer only after the interrupts are activated, you know, because when we get an answer, this is done through an interrupt handler. So I'm gonna request the gateway IP okay, and let's see, in here when we receive data, I'll just print the data out before we handle it. And I think I'll just, before we do that, I'll make a few line feeds. So that we get a clear screen first, and then we can see the data that is coming, if it's coming, I hope. Okay. I don't know the syntax for that. Let's see. Okay, it tells me it has sent the data. Okay, let's look at this whole thing. So 6 times F, the broadcast address, that's correct. This is our own MAC address. Let's see. Yeah, this is the same as our MAC address here. We have 806. That's strange. I mean, 0x806 it should be in big endian, so it should actually be the other way around, I think. This is really strange. It seems like all the bytes are the wrong way around. Okay, here's the data. So here starts the data. Hardware type 0001. Then we're talking about IPv4. Hardware address, protocol address. 0001 is the request. Our own IP address. Our own, this is our own MAC address, correct? This is our own IP address, the one that we've set. Then the destination MAC address and destination IP address hasn't been set. Oh, wait, it actually has been set. Why isn't it printed here? Okay, this should be 32. Hey, this looks differently. I think we have gotten some result. So here we print the data that we've received, right? So yeah, I'll limit this to something like 64. Okay, we have sent this, which we had already determined seems relatively correct. And here we have received something which is directed at us. This looks very good. This seems to be the MAC address of the gateway, the virtual gateway. Then 806 is ARP. And then it asks us for our IP address. Here, protocol 800, size 6, size 4. Then again its own MAC address. Yes, 0. Yes. This is the protocol type. Here starts the ARP message. So this is type Ethernet, protocol IP, size, hardware size 6, protocol size 4, MAC address, IP address. Then 0002 is the command, which says it's a response. You know, we had sent a request and now it sent a response. Then here it has its own MAC address again, its own IP address, and the recipient is our MAC address and our IP address. Yes, this looks really, really good. Yes. So, yeah. What we did worked. What can you say about this? We are really communicating with the network. Yeah, I'm totally happy now because this was really a lot of code which we couldn't test before, so there was really a big potential for something not to work. But yeah, now we really see it has worked. We have sent an ARP request. We have received an ARP response. Yeah, this is nice. I'm really happy about this. So this should be really enough for today. I hope you are as excited as me, because now you can really go and start communicating with the network. Maybe you'll start writing your own IPv4 handler now. IPv4 isn't that hard. I mean, it's harder than ARP, but I can tell you far simpler than TCP. So if you go for IPv4, then the next thing you should do is ICMP. And after that you should do UDP. But I think we will have time to go into these topics in these appendices also. So yeah, great day. So a lot of code that we've written. I think this was 2 videos. This was 1 video, although I haven't cut it yet. Maybe it becomes 2 videos and another video. So the code that we've written over a course of 4 hours, we couldn't test before. Now we've tested and it works. Yes. So I think this is really an awesome feeling because now you are really communicating with the network. So So tune in next time when we start looking at the IPv4 protocol. And see you next time. Don't forget to subscribe so that you don't miss the video about IPv4. And if you liked this video, hit like. I liked this video. So I don't know if I can hit like, but if I can, I will, because I really like this now. We really got the data that we wanted. I'm so happy now. Okay, so see you next time, and bye.